Alrighty, hey there, this is Dylan Alexander, and today I will be demoing the Guitar Hero application that I created with my group for the Natural Language Processing class at KSU in the fall semester of 2023. So, quick overview of what the Guitar Hero application is. This is a research type project in which we are trying to see how closely can ChatGPT mimic a call center care representative. So that person who answers the phone when you have something wrong with like maybe a fraudulent charge, or you want to dispute something over an American Express account, that person that you're talking to, how closely can a large language model mimic that person? So I think the way I'm going to go about demoing this, we have the overview. We're going to look at what type of data is fed into this application, how that data is broken down and pre-processed, and then we'll understand what output we're getting from ChatGPT. How is that compared to what has actually been said inside the transcript, and how we're calculating a score from that to decide whether or not ChatGPT passed the level, so to speak. So, real quick, the idea behind this project was to sort of go about it in a Guitar Hero way. So, Guitar Hero, we can look it up right here, real quick. So in Guitar Hero, you have this meter. This meter will stay in the positive, like in the green, if you hit all the notes. The second you start missing notes, it'll go down to the red. The application that we're working on pretty much does the same thing. So it will calculate an overall average score and let us know whether or not ChatGPT did a successful job in responding to the customer's request. And that metric is solely based off of how close ChatGPT's response was to the customer care representative's actual response in the transcript. So let's go ahead and look at the call center transcript. The way that this is formatted is through tabs. So it's a tab separated value type of file. We have the things that we care about are the channel and the phrase. All of the rest of this is pretty useful information, like the type, the score, how closely, like how confident is the system that this is what was said, and then the start time and end time. All that's useful information, but for this application, we're only going to use the channel and the phrase. So the channel, ones are going to denote a customer, and zeros are going to denote an agent. So the agent is that customer care representative. And the way that we decipher turns is we iterate through each line of the transcript, and then the second the channel switches, we know that that person is done speaking. Now, there can be some issues with this if people are talking over each other, if one person's not loud enough and something weird was said, but all of that is handled before the data gets into this transcript. So there's a pretty high certainty that this is a very accurate representation of what was actually said. So we can now switch over to, now that we know what the data looks like, we can switch over to the CLI and understand how that data is pre-processed. So to begin, we have all of the credential authentication processes in place, calls rather, to communicate with the OpenAI API. So this is a pretty basic Azure license. I set this up with an Azure instance. We can go take a look at that right now. Um, just a super simple. I ended up paying for it. Not a huge deal. Um, what's really important here is the type of models that I've deployed from the Azure instance. So we have just a regular ChatGPT 3.5 large language model to play with, but then more importantly, I guess they're both important, but one of the key things here is that OpenAI offers an embedding model. And this is a very, very straightforward thing to use. You have a sentence, you pass it into this embedding model, and it gives you a vector representation of it. And it's really that simple. So that was very, very useful. Like, we did not have to go through the process of making this ourselves. It was already there provided for us. So I just have some basic authentication steps in place at the beginning of this CLI program. Then I switch over to parsing the transcript. So I have the path hard coded onto my machine. I create a pandas data frame from the CSV transcript, and I'm only pulling out those fields, namely the channel and the phrase. I'm only pulling out those fields into the data frame. And then from there, I will separate each turn, and I will create a tuple. So I'll have a turn, one of these, and then the tuple, the other value in the tuple is the speaker. So in that case, that would be the customer. After that, I will create subsets of turns. So in order to give ChatGPT adequate information to create a response from, we're going to need about a 3 to 4 turn exchange. So customer says something, agent says something, customer says something, agent says something. Then we can pass that into ChatGPT to get a response. Now, the key point here is that whenever we create a subset of turns, it's always going to end in a customer request. So these transcript subsets, they all end in customer requests. So you can imagine that, so we see here, need another IP address to send reset code. Okay, let's pull it up, yada, yada, yada. His information. It's going to end in a customer request. Hopefully that makes sense. It's not going to end in an agent response, because then ChatGPT would have nothing to respond to. So after that, we take the agent's actual responses. So we're looking kind of into the next succeeding subset. We're taking the agent's actual response, and then that's what we're going to use to create an embedding that we can compare to ChatGPT's actual response. So we do this many times over the entire transcript, and then we create this thing that I called an embedding proximity sum. And this is pretty much just an average. So based off of how many subsets did we create, so how many out of maybe a transcript that has, let's call it 30 turns, we created 5 or 6 subsets of those turns. Those turns are comprised of like 5 or 6 turns each. Each subset is 5 or 6 turns. And then a score is calculated for each of those subsets. And then we can average them out based on the length. And then that'll be our final score. So we can give it a shot right now. Okay, so we can kind of look at the output here a little bit. So in this case, the agent actually said, "Oh, do you have the account number handy?" And the next best sentence, according to ChatGPT, and I actually also normalize it before, so there's no errors in terms of parsing with the embedding. So agent actually said, "Oh, do you have the account number handy?" ChatGPT said, "I'm sorry for the confusion earlier. Do you have a billing statement or an email from the provider to get the states that states your account number?" So pretty similar there. And that one the cosine distance between these two statements is 0.832, and we get that average over every single one. So every single one of these numbers is just averaged out, and our final is left with 0.793, which is pretty decent. I would be willing to guess that in the next 10 years, call center representatives are completely abstracted away. And we'll have large language models that are very well trained doing that job. So, thank you so much for your time today. Really enjoyed working on this project.